Good morning, students. Today we will talk about the prism and the deviation by the prism. The angle of deviation we have to calculate in this case. And first of all, I will talk about what's the prism. Prism is a portion of a transparent medium. This is a prism. This is a portion of a transparent medium. If you see, it's having a surface. This is and this toward this side. These are the two surfaces which are at angle to each other, which are at incline to each other, and the angle made by these is called angle of prism. Prism is having 5 faces. One face is this one, second is this one, third is on this side, fourth is on back side, this one on the back side. You can say this is the fourth one, and fifth one is on the lower side. This lower side, that's the fifth one. So it's having a 5 surfaces. First, in this case, these two are refracting surfaces. And this is an angle of prism. Any ray that's striking on the surface of the prism, if I mark normal, then it will bend towards the normal. And I mark second normal, it will bend away from the normal. It has to go in this direction, but it move towards this direction. So when it moves towards this direction, this angle is called angle of deviation. This angle is angle of deviation. And this, when we draw a normal over it, this is point O. This is any ray P, it's striking on the surface Q. This N1O is one normal and N2O is another normal. This is R, this is S. This ray is known as incident ray, and this is known as emergent ray. And here, this angle is called incidence angle, and this angle is refracted angle R1. And here, this is another angle R2, and this angle is emergent angle. And this was upper top angle is, this is angle of prism. Now, we will talk about how the deviation is taken place. What's the angle of deviation? In this case, if I denote, this was angle of deviation and this is angle of incidence. If I start increasing the angle of incidence, this angle of deviation decreases. At one angle of incidence, angle of deviation becomes minimum. When the angle of deviation becomes minimum, in this case, that angle of incidence becomes equal to angle of emergence. We have to describe this one. How this is taken place and how this has to be done. One, here we calculate, one is called deviation. Secondly, we are calculating in this case, we are denoting in this case dispersion. 2 aspects we have to take into account. First aspect, suppose I will talk about, this is a prism. This is A, this is B, and this is C. And a ray of light that's incident on its surface is this one, that's called PQ. And if I denote the normal to it, this was O point, this N1O is a normal. After this refraction, it will move in this direction, that's QR. We draw second normal, and now it will bend away from the normal. This ray comes to be the emergent ray. Here this is angle of refraction R1, this is R2, and this is E. If I draw it backward and this on this direction, then this angle comes to be angle of deviation, and this was angle A. Now in this case, if you see a quadrilateral, that is A, Q, O, R. We are having a quadrilateral, that is A, Q, O, R. Always sum of opposite angles is 180 degree in case of quadrilateral, or we can say all the angles are 360 degree. So all the angles in this case is quadrilateral is opposite angles. Angle A plus angle O is 180 degree. Angle A and angle O is 180 degree. And in this case, another point we will consider, that's we are having a triangle, this one, QOR. QOR. Triangle QOR. Sum of angles is, that's E1 plus angle O is 180 degree. So this is one is in case of quadrilateral and this one in case of triangle. Now from here we are having angle A plus angle O is 180 degree, angle R1 plus R2 plus O is 180 degree. From here we can denote that angle A plus O is equal to, this is number 2 and this was number 1. That's equal to angle R1 plus angle R2 plus angle O. So you can cancel out this one. So angle A is R1 plus R2. So angle A becomes R1 plus R2 angle. And another is, this angle of deviation is outer angle in case of triangle. Angle of deviation is outer angle in triangle AQR. This AQR, this angle becomes I minus R1 and this becomes the E minus R2. From this, the outer angle becomes equal to the sum of two opposite angles. So outer angle, this angle delta is equal to I minus R1 plus E minus R2. So this is I plus angle E, this is minus R1 plus R2. That's angle delta. So angle delta is equal to I plus angle E minus angle A, because R1 plus R2 is equal to A. So the angle of deviation plus angle of prism is equal to angle of incidence plus angle of emergence. So these are the two values in this case. So angle of prism becomes plus angle of deviation becomes equal to angle of incidence plus angle of emergence. So this is one of the case in this case. Now we have to consider angle of minimum deviation and refractive index of a prism. How we calculate angle of minimum deviation? When we have to calculate the angle of minimum deviation, we will say angle of incidence and angle of emergence both are equal. In that case, means this was a prism and this was incident ray, this was normal, it goes in this way, this was another normal, this is emergent ray, this is emergent angle, and this was incident angle. So this incident angle and emergent angle becomes equal when the angle becomes, this deviation becomes minimum. Angle of deviation becomes minimum, then this is the value. Then I have to talk about now angle of deviation was equal to angle of incidence plus angle of emergence minus angle of prism. Now these two angles are equal, so you can take it as a 2i minus angle of, that's prism, into angle of deviation. You can write down in this case this one. So secondly, we have to prove that now the angle I becomes the minimum deviation plus angle A. So angle I becomes minimum deviation plus angle of prism divided by 2. Now, second thing, when this E and I are equal, this R1 and R2 is also equal. So R1 becomes equal to R2 is equal to R, we can say. So now R1 plus R2, that was equal to angle A, and 2R is equal to angle A. So R is equal to A by 2. We know that refractive index of a prism is equal to sine I upon sine R. Sine R. I is equal to that sine, in this case, delta M plus A by 2 upon sine A by 2 is equal to refractive index. So in this way we can denote the relationship between refractive index and angle of minimum deviation. So this is a relationship between refractive index and minimum deviation. So next in this case is we have to show the minimum deviation, the ray thus passes symmetrically through the prism. I was saying the ray thus passes symmetrically through the prism, means R1 and R2 are equal. It most probably parallel to the lower phase. It passes symmetrically through the prism and it passes parallel to the base. When it passes parallel to the base, this R1 and R2 are equal and E and I are also equal to each other in this case. Next topic, we have to consider that refractive index with wavelength. How refractive index relate with the wavelength? In this case, refractive index relate with the wavelength. That's according to mu is equal to A plus B upon lambda square. This is Cauchy's formula. It is according to the Cauchy's formula. Refractive index is inversely proportional to the wavelength. For example, this is a prism I am showing. If I am sending, this is an incident ray, this is the red wavelength, and it is bending towards the, means away, you can say it is bending, this is angle of deviation for red color. And now I am having, this one is a violet ray, this is another ray that's coming, and it is, that's bending is more. This is violet, this is red. More the wavelength, lesser the refractive index. Lesser the wavelength, more the refractive index. So this is according to, so refractive index for violet is more as compared to refractive index for red. So this, if this is a prism, I am supposing any ray that's passing through the prism, it gets dissociated into 7 colors. If it dissociates into 7 colors, this is called dispersion. And lower is, that's violet. And upper one is red. If I pause it, so this is angle of deviation for red, and this is angle of deviation for violet. So angle of deviation for violet is more as compared to angle of deviation for red. So this means refractive index for violet is more as compared to red. This means refractive index is inversely proportional to wavelength. Lesser the wavelength, more the refractive index. More the wavelength, lesser the refractive index. So refractive index of a medium for violet color is maximum, more than the refractive index of a medium for red color. So it is inversely proportional to wavelength. Next phenomena, we have to show the angle of deviation. In this case, dispersion by the prism. How we show dispersion by the prism? That's dispersion by a prism is, this is dispersion by a prism. What's the meaning of dispersion by a prism? The phenomena of bending. A beam of white light when passes through the prism, a number of different wavelengths is, it is, white light is dissociated into the phenomenon. This is a prism. The phenomena of, this is a white light. The phenomena of splitting of white light into different colors, different wavelengths. Phenomena of, the phenomena of splitting of white light into different wavelengths of light when it passes through a prism. The phenomena of that splitting of white light into different wavelength of light when it passes through the prism. So this was an incident ray, and this, it splits up into these colors. So this one is angle of deviation for red, and this is angle of deviation for violet. So this phenomena is known as dispersion. So dispersion, we are writing angle of deviation is mu minus 1 into A. So for violet, it's mu V minus 1 into A. For red, it's mu R minus 1 into A. So net deviation for different colors, if I say mu R is more, means the mu V is more than the mu R, that's R, then deviation for red is lesser as compared to the deviation for violet. If I subtract, this is number 1 I took, and this is number 2 I took. I subtract number 2 from 1. So delta V minus delta R is mu V minus 1 into A minus mu R minus 1 into A. So mu V into A minus mu R into A plus A. So this A cancel out. So mu V minus mu R into A is equal to delta V minus delta R. So delta V minus delta R is equal to, this is known as angular dispersion. So this is called angular dispersion for violet and red color. Angular dispersion produced by the prism depend upon the refractive index, nature of the material of the prism, and also depend upon the this is depending upon the nature of the prism, and it is also depending upon the angle of prism. So we have that this was angular dispersion, this was equal to mu V minus mu R into A. So this is depending upon two factors. Number 1 is this one, and second is this one. So this factor is the nature of prism. Number 2, this is angle of prism. So angular dispersion is depending upon two factors. Angle of dispersion is depending upon two factors. Now I will consider different topic. That's another topic I will consider. That's thanks. Have a nice day.